Now let's talk about the voltage standing wave ratio. Remember, when we have a standing wave, it has an envelope that has a maximum and a minimum value to it. The voltage standing wave ratio is Vmax divided by Vmin. We can read that in two different places on the Smith chart. One is right here on this axis, and the other is right here. Both of these axes are going to give us the same value. So what we do is we plot the load impedance, or whatever other location we want to find the standing wave ratio. And let's say that ZL is 100 plus J 100 ohms on a 50 ohm transmission line. So we're going to plot 2 plus J2. That's right here, where the imaginary part is 2 and the real part is 2. Here is our ZL value. The way we're going to find the standing wave ratio, which remember is just a number, it doesn't have any angle or phase associated with it, is we're going to draw, again, our straight line from the center through our point, and we're going to mark the distance on our piece of paper. And then we're going to bring that down to this axis right here, and we're going to mark that distance again, and let's read this value. Looks like it's 3, 4, 5, 6. We have a standing wave ratio of 6. Now let's also look down here on this other axis. I'm going to take my center point and put it at the center, and I'm going to measure my value right here. Looks like it's also 6. Now what if I had wanted to find that in decibels? So here is my standing wave ratio, which I can read off in dB. Now the other thing that we want to be able to do with the Smith chart is define and notice the location of the minimum and maximum values. So right over here on this axis is going to be the location of the voltage minimum, and on this axis it's going to be the location of the voltage maximum. So let's see what happens. As we have our load right here, and we travel towards the generator, in this direction, wavelengths toward the generator, we can see that the first thing we're going to come upon is going to be a voltage maxima. It's going to go up first. And then, as we go further, we're going to come to the location of the voltage minimum. So here we can actually read the location of the voltage maximum. If we want to know this distance, let's call it D. It's actually L max. This distance L max is going to be this value, which is 0.25. I'm reading on my outside towards the generator axis, minus this value right there, which is 0.21. So my L max is at about 0.04 wavelengths.